The universe is vast, so vast that it's hard to truly understand. But every corner, every shadow holds something unexpected. We're about to travel beyond the familiar, diving into the bizarre and the unexplained. There are planets that roam the cosmos with no star to call home, mysterious forces that stretch the universe apart, and invisible matter that shapes galaxies without us ever seeing it. These aren't just random facts, they're pieces of a cosmic puzzle scattered across the void, waiting to be noticed. As we drift through these wonders, don't rush to understand it all. Let the immensity of space unfold slowly. No need to grasp every detail, just let the journey happen. Drifting silently through the void, further than any human-made object has ever traveled, the Voyager spacecraft are our most distant messengers to the universe. They have outlived their creators, outlasted their original mission, and now wander endlessly through the dark, carrying a golden message that may never be heard. It all started in the 1970s when scientists realized they had a rare opportunity. Once every 175 years, the outer planets align in such a way that a spacecraft can slingshot from one to the next using their gravity, reducing travel time significantly. If they missed this chance, they wouldn't get another for nearly 2 centuries. So, they built 2 identical probes and launched them in 1977, sending them on a journey that would change how we see the solar system forever. Jupiter was the first stop. From a distance, it had always been a swirling giant, but Voyager revealed a world far more violent than anyone had imagined. The Great Red Spot, a storm larger than Earth, churned with winds that had raged for centuries. Then came an even bigger surprise. Io, one of Jupiter's moons, was covered in volcanoes that spewed sulfur hundreds of miles into space. Until that moment, scientists thought Earth was the only volcanically active body in the solar system. Saturn was next, and with it came the first detailed look at its rings. What seemed from Earth like smooth, solid bands turned out to be a complex system of countless icy particles ranging in size from dust grains to mountains. Some sections were twisted, braided, and broken up by invisible forces, tiny moons tugging at them, carving gaps in the rings as they orbited. One spacecraft continued onward, giving humanity its first and only close-up view of Uranus. Before this, it had been nothing more than a pale blue dot in telescopes, but Voyager revealed an odd world tipped on its side, likely the result of a violent collision in its past. Instead of swirling bands like Jupiter or Saturn, its atmosphere was eerily featureless, a smooth, unbroken expanse of cyan gas. Even its magnetic field was strange, tilted and off-center, sweeping through space in a lopsided, chaotic pattern. The last planet it would visit was Neptune, a world so distant that sunlight takes 4 hours to reach it. If Uranus seemed quiet, Neptune was the opposite. Its deep blue atmosphere was turbulent, with the fastest winds in the solar system reaching nearly twice the speed of sound. There was even a massive storm, similar to Jupiter's Great Red Spot, but darker and more mysterious. Unlike Jupiter's storm, which had lasted for centuries, Neptune's vanished just a few years later. No one knows why. After this, their primary mission was complete, but they weren't done yet. Scientists realized the probes still had power, and with no way to bring them back, they decided to let them keep going. In 1990, Voyager 1 turned its camera back toward Earth for one final photograph. From 3.7 billion miles away, Earth appeared as nothing more than a single pale dot, barely visible in the vast darkness of space. That one image inspired one of the most humbling reflections ever spoken. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was lived out their lives. Every king and peasant, every war and peace, every joy and sorrow, all contained within that tiny, fragile speck. A reminder that in the grand scale of the cosmos, all of human history has taken place on a mere dust mote, floating in the sunbeam of a single star. But the Voyager probes were still moving. They kept going, past Pluto, past the outer reaches of the solar system, and toward the vast emptiness beyond. In 2012, Voyager 1 crossed the heliopause, the invisible boundary where the sun's influence ends and interstellar space begins. It became the first human-made object to leave the solar system. Voyager 2 followed years later. Now, they drift alone, carrying with them a time capsule, a golden record, designed as a message for any civilization that might one day find them. On it are sounds of Earth, greetings in 55 languages, the songs of whales, the laughter of children. There's music from Bach to Chuck Berry, and even a message from the President of the United States at the time, wishing goodwill to whatever beings may one day hear it. But the truth is, no one knows if they will ever be found. The odds of another civilization intercepting them are astronomically low, yet they exist, floating endlessly through space, silent witnesses to the infinite. They will outlast Earth, outlast the sun, and perhaps even outlast humanity itself. Even when their power fades and their signals go silent, they will continue their journey, drifting for millions of years among the stars. And maybe, just maybe, long after we are gone, someone, something will find them. A final whisper from a distant world, telling the universe that once, long ago, we were here. For billions of years, the universe has been a stage for the most spectacular and violent events imaginable. Stars are born, blaze brightly for eons, and then collapse into nothingness. Planets form from dust, gather atmospheres, and sometimes, just sometimes, cradle life. But the vast majority of space is silent, an endless dark ocean where time stretches beyond human comprehension. One of the most mysterious objects lurking in this cosmic ocean is the rogue planet. Unlike Earth, which orbits the sun in a steady, predictable path, rogue planets are wanderers, worlds that have been cast out of their home star systems, doomed to drift alone through the void. Scientists estimate there could be billions of them, scattered across the galaxy, hiding in the darkness where no sunlight reaches. Without a star to warm them, these planets should be frozen and lifeless, but some may still generate heat deep within their cores. The intense pressure from their interiors could keep underground oceans liquid for billions of years, just like the hidden seas beneath the icy crusts of moons like Europa and Enceladus. If life can exist in the deep, sunless waters of Earth's ocean trenches, where hydrothermal vents spew boiling chemicals into the abyss, then who's to say something similar couldn't thrive on a rogue planet? And then there are the planets that challenge everything we thought we knew. Take HD 189733b, for example, a gas giant located 64 light-years away, with weather so extreme it seems more like science fiction than reality. The atmosphere is laced with silicate particles, meaning it quite literally rains molten glass. But that's not even the worst part. The winds on this planet blow at 5,400 miles per hour, 8,700 kilometers per hour, nearly 7 times the speed of sound. If you stood on its surface, if such a thing were possible, you wouldn't just feel a strong breeze. You'd be torn apart in seconds by a storm of molten glass, moving at hypersonic speeds. And then there's the legendary planet Gliese 581c. When it was first discovered in 2007, scientists were thrilled. It was the first potentially habitable planet ever detected outside our solar system. It orbits a red dwarf star, much smaller and dimmer than our sun, but at just the right distance to be in the Goldilocks zone where liquid water could exist. But there was a catch. Because it orbits so close to its star, Gliese 581c is likely tidally locked, meaning one side is permanently bathed in daylight, while the other is stuck in eternal darkness. On one side, temperatures could be scorching, hot enough to boil water instantly. On the other, they could be cold enough to freeze air solid. The only place where life could survive is in the thin twilight zone, a narrow strip where day and night meet, creating a world of endless sunsets. And yet, despite the extremes, some scientists still believe such a planet could support life. If an intelligent species evolved there, their entire civilization might exist in a thin, habitable ring around their world, with one horizon always in darkness and the other locked in an endless dawn. But these are just exoplanets, worlds that exist beyond our solar system. If we look closer to home, we find that even the planets we thought we knew hold terrifying secrets. Take Venus. Often called Earth's twin due to its similar size and composition, Venus should, in theory, be a paradise. Instead, it is a hellscape. Its surface is hot enough to melt lead, thanks to an out-of-control greenhouse effect that has turned the planet into a sweltering, unlivable nightmare. The atmosphere is thick with carbon dioxide, and the clouds are made not of water, but of sulfuric acid, which rains down in corrosive torrents before evaporating in the heat. Even stranger, Venus has a bizarre feature known as superrotation. Unlike Earth, where the atmosphere moves with the planet, Venus's winds move so fast that they circle the entire planet in just 4 days, far faster than the planet itself rotates. Imagine standing on the surface, watching clouds race by at hurricane speeds, completely obscuring the sky. If you could survive the crushing pressure, the suffocating heat, and the acidic rain, you'd still find yourself in a world where the sky swirls chaotically overhead with no true sunrise or sunset to mark the passage of time. And then there's Mars, the planet that may one day become humanity's second home. But for all its intrigue, Mars is a dead world, with a past that hints at something far more active. Billions of years ago, it was warm and wet, with rivers, lakes, and possibly even oceans. But over time, it lost its magnetic field, allowing solar radiation to strip away its atmosphere. What was once a world teeming with water became a frozen desert, with only the faintest remnants of its past left behind in dried riverbeds and polar ice caps. Yet even today, Mars still shows signs of activity. Every now and then, dark streaks appear on its slopes, almost as if something is moving beneath the surface. Scientists believe these might be caused by seasonal flows of briny water that seeps up from below the surface when temperatures rise. If that's true, then Mars isn't entirely dead. And where there is water, there is always the possibility of life. But as we search for life beyond Earth, we must also consider something even stranger: the possibility that we may not be alone, even closer to home. Some scientists have speculated about the idea of shadow biospheres, forms of life that exist right alongside us, but that are so fundamentally different from what we consider life that we've never noticed them. It's possible that somewhere on Earth, perhaps in the deep sea or in caves hidden miles below the surface, there are microbes that don't rely on DNA or that function in ways so alien that we wouldn't even recognize them as living organisms. If such life exists here, it raises an even bigger question. Could entirely different forms of life exist on other planets, ones that don't fit into our definitions at all? The universe is full of mysteries, some terrifying, some beautiful, and some so strange that they challenge everything we think we know. But for all its dangers and extremes, space remains our greatest frontier, a place that calls to us with the promise of the unknown. And so we continue to look up, to search, and to wonder. Because somewhere out there in the darkness, there is always something waiting to be discovered. Out beyond the planets we know, past the orbit of Neptune and the icy realm of Pluto, lies a region of space so vast and unexplored that it might as well be a cosmic graveyard. This is the Oort cloud, a shell of icy bodies that stretches so far from the sun that its outer edge may be a full light year away. Unlike the asteroid belt, where rocky fragments orbit in a relatively confined region, the Oort cloud is more like a vast, spherical fog of ice and rock, a place where the sun is just another distant star. This is where comets are born, chunks of frozen gas, dust, and rock that spend most of their existence in the cold, undisturbed darkness. But every now and then, one of these icy travelers is nudged by the faint gravitational pull of a passing star or the slow churn of the Milky Way itself. When that happens, the comet begins a long, slow fall toward the sun, a journey that can take thousands, even millions of years to complete. And when they finally arrive, they put on one of the most breathtaking displays in the solar system. As a comet approaches the sun, the heat begins to vaporize the ice, creating a glowing halo called a coma. The solar wind then sweeps this material away, forming the comet's tail, which can stretch for millions of miles. What's even stranger is that the tail always points away from the sun, no matter which direction the comet is moving. This is because the charged particles of the solar wind push against it, shaping it like a streamer caught in a constant breeze. One of the most famous of these travelers is Halley's Comet, which swings by Earth once every 76 years. It has been recorded by ancient civilizations for over 2 millennia, appearing as a mysterious omen in the skies before vanishing again into the darkness. If you were to stand on its surface, you'd see a landscape unlike anything on Earth, a world of jagged ice, blackened rock, and towering geysers that erupt as sunlight warms the frozen ground. And yet, for all its drama, A comet is little more than a dirty snowball, a fragile relic from the earliest days of the solar system, carrying within it the untouched building blocks of planets and moons. But comets aren't just beautiful, they can also be deadly. 66 million years ago, an object 6 miles wide slammed into what is now the Yucatan Peninsula, wiping out the dinosaurs and nearly every species on Earth. The impact was equivalent to the explosion of billions of nuclear bombs. The sky turned black with soot, firestorms raged across continents, and within months the planet fell into a deep, unrelenting winter. For decades, scientists debated whether the object that struck Earth was a comet or an asteroid. Recent studies suggest it may have been a long-period comet, one that originated from the distant Oort cloud before being thrown inward by the gravity of Jupiter. If that's true, then it means the very same celestial bodies that create stunning night sky spectacles also have the power to reset life on Earth in an instant. And yet, Earth has survived. Again and again, the planet has been battered by cosmic impacts, gamma-ray bursts, and supervolcanic eruptions, and yet, against all odds, life has endured. But what if, somewhere out in the galaxy, there was a world that didn't get so lucky? Scientists have long suspected that there may be planets out there that once harbored life, only to have it wiped out by some cosmic disaster before it had a chance to escape. A rogue black hole passing too close, a supernova irradiating the surface, or a massive asteroid impact that shattered a world entirely. There could be entire civilizations that never had the chance to reach the stars, their planets now barren and lifeless, graveyards of what could have been. And then, there are the worlds that never had a chance in the first place. Some planets, like Kelt 9b, exist in such extreme conditions that the very idea of life seems impossible. Kelt 9b is a gas giant hotter than most stars, with daytime temperatures reaching 7,800 degrees Fahrenheit, 4,300 degrees Celsius. The heat is so intense that molecules can't even stay together. The atmosphere is constantly being stripped away by its parent star, like steam rising from a boiling pot of water. It's a planet that is quite literally evaporating into space. And then there are the planets where the laws of physics seem to bend. One such world is WASP 12b, a gas giant so close to its star that it is being torn apart by gravity. The planet is stretched into an elongated rugby ball shape as its outer layers are pulled away, forming a trail of gas that spirals toward the star. In a few million years, it will be gone entirely, swallowed by the very star that once sustained it. These worlds remind us that space is not a gentle place. It is a realm of violence and destruction, where planets can be vaporized, atmospheres stripped away, and stars born in bursts of fire, only to collapse into cold darkness. And yet, within this chaos, there is also unimaginable beauty. Somewhere in the heart of a distant nebula, new stars are forming right now, their light still hidden behind clouds of gas and dust. These stellar nurseries are the birthplaces of entire solar systems, the same kind of place where our own sun was once formed, 4.5 billion years ago. And one day, far in the future, the cycle will continue. Our sun, now a blazing beacon of warmth and light, will eventually grow old. In about 5 billion years, it will swell into a red giant, expanding so much that it will swallow Mercury, Venus, and possibly even Earth. The oceans will boil away, the atmosphere will be stripped, and our world will become an airless husk, just like Mars. But the sun's story doesn't end there. After shedding its outer layers, it will shrink down to a white dwarf, a hot, dense remnant no larger than Earth, glowing faintly with the last heat of its long life. Over trillions of years, it will slowly cool and fade, until all that remains is a cold, dark ember, a black dwarf, drifting silently through space. But long before that happens, long before the sun meets its end, humanity may no longer be bound to this world. Perhaps by then we will have left Earth behind, spreading out among the stars by ensuring that even when our home planet is gone, our story will continue. Because if there is one truth the universe has shown us, it is that nothing lasts forever, but within every ending there is always the chance for a new beginning. Somewhere, out in the depths of space, new worlds are forming, new stars are igniting, and perhaps, just perhaps, new civilizations are just beginning to look up at their skies, wondering, like we do, what else might be out there. And maybe, one day, we will find them. As we drift further into the depths of space, we leave behind the familiar and venture into the unknown. Beyond our galaxy, beyond the clusters of galaxies bound together by gravity, lies a realm so vast and empty that it defies comprehension: the cosmic voids. These are not just empty spaces between galaxies. They are immense regions where almost nothing exists, stretching for hundreds of millions of light years. If you were to stand in the middle of one, assuming there was something to stand on, you would see nothing in any direction. No stars, no galaxies, just an unfathomable darkness. One of the largest of these is the Boots Void, a vast region of space that spans nearly 330 million light years across. It is so empty that if the Milky Way had been inside it, we wouldn't have even known there were other galaxies until modern telescopes were developed. Scientists still don't fully understand how these voids formed. The universe, as we know it, is structured like a cosmic web, with galaxies and clusters strung together in immense filaments. The voids are the empty spaces between these structures, places where gravity never managed to pull enough matter together to form stars and planets. And yet, even in these vast nothingnesses, there are secrets waiting to be uncovered. Some scientists theorize that these voids may be home to dark energy, the mysterious force that is accelerating the expansion of the universe. Others believe that if advanced civilizations exist, they might deliberately place themselves inside voids to avoid detection, a kind of cosmic camouflage that keeps them hidden from prying eyes. But voids aren't the only mysteries lurking in deep space. Consider the Great Attractor, an enormous, invisible gravitational anomaly that is pulling entire galaxies toward it at speeds of millions of miles per hour. We can't see what it is because it's hidden behind the thick disk of our own galaxy in a region called the zone of avoidance. But whatever it is, it has the gravitational pull of tens of thousands of galaxies, and it's dragging the Milky Way and everything in our local group toward it. The leading theory suggests that it's a colossal concentration of dark matter and galaxy clusters, buried behind the dense gas and dust of the Milky Way. But because we can't see it directly, it remains one of the great unsolved puzzles of the universe. And then there are the stars themselves. While most stars live for billions of years, some are born to die young. Take Wolf-Rayet stars, for example. These are some of the most massive, most luminous, and most unstable stars in the universe. They burn through their fuel at an astonishing rate, throwing off layers of gas and radiation in violent stellar winds that move at millions of miles per hour. Eventually, they explode in spectacular supernovae, leaving behind either a neutron star or a black hole. But some Wolf-Rayet stars are so extreme that when they die, they create something even more terrifying: a gamma-ray burst. Gamma-ray bursts are the most powerful explosions known in the universe, releasing more energy in a few seconds than the sun will produce in its entire lifetime. If one were to occur within a few thousand light years of Earth and aimed in our direction, it could strip away our planet's atmosphere, leaving us completely exposed to the deadly radiation of space. Thankfully, these events are incredibly rare, and most happen in distant galaxies, but they serve as a reminder of just how violent and unpredictable the universe can be. But not all stars end in destruction. Some simply fade away. Take red dwarfs, for example. These are the smallest and longest living stars in the universe. While a massive star like our sun will burn out in about 10 billion years, a red dwarf can last trillions of years, longer than the current age of the universe itself. This means that no red dwarf star has ever fully died, because the universe simply hasn't been around long enough for one to reach the end of its life. In the far, distant future, when all the big stars have burned out, it will be red dwarfs that remain, the last flickering embers of a dying universe. And what happens when the universe itself grows old? Scientists believe we are currently living in the stelliferous era, the age of stars. But in the far future, billions and trillions of years from now, the universe will enter a new stage, the degenerate era. By then, most stars will have burned out, leaving behind only white dwarfs, neutron stars, and black holes. Planets will drift in the darkness, their suns long gone. Galaxies will lose their structure, slowly dissolving as their stars are ejected into intergalactic space. But even this is not the end. As time stretches on, black holes will begin to evaporate due to a process called Hawking radiation. Over incomprehensible timescales, trillions upon trillions of years, even the most massive black holes will shrink away to nothing, releasing their energy back into the universe. And what remains after that? Eventually, the universe may enter the dark era, a time when all that's left is a thin, cold mist of subatomic particles drifting endlessly through an empty cosmos. There will be no light, no heat, and no way to tell that anything ever existed at all. But some scientists have proposed a different possibility. If the universe is expanding due to dark energy, could it one day rip itself apart? This is the idea behind the Big Rip, a theory that suggests that as dark energy grows stronger, it could eventually overwhelm the forces holding galaxies, stars, and even atoms together. If that happens, everything, from the largest galaxy clusters to the smallest particles, will be torn apart until only pure energy remains, or perhaps something even stranger will occur. Some theories suggest that in the far, far future, quantum fluctuations could cause a new Big Bang to occur, a rebirth of the universe from nothing. If this is true, then the cycle may never truly end. One universe collapses and another begins, an endless chain of creation and destruction stretching forever through time. And somewhere in that vast, unimaginable future, perhaps new civilizations will rise, new stars will shine, and new eyes will look up at the night sky, wondering, as we do now, about the mysteries that lie beyond. One of the strangest and least understood mysteries of the universe is something so vast that it affects everything, yet remains completely invisible. We're talking about dark matter, the ghostly substance that makes up nearly 85% of all the matter in the universe, but can't be seen, touched, or directly detected. We know it exists because of its gravitational influence. If you look at a spiral galaxy, like the Milky Way, you'll notice something strange. The stars in the outer edges are moving way too fast. According to the laws of physics, they should be flung into space because there isn't enough visible mass holding them in place. And yet, they stay. Something unseen is providing the extra gravity necessary to keep galaxies together. That something is dark matter. But what is it made of? Scientists have no definitive answer. One theory suggests that dark matter is composed of exotic, never-before-detected particles called WIMPs, weakly interacting massive particles. These particles might pass through normal matter without ever interacting with it. Billions could be flowing through your body right now, and you wouldn't even notice. Another theory suggests that dark matter might be made of primordial black holes, tiny remnants from the earliest moments of the universe that are too small to detect, but still exert gravitational influence. The truth? No one knows. Despite decades of searching, no direct evidence of dark matter has ever been found. It remains one of the biggest cosmic puzzles of our time. But if you think dark matter is strange, it's nothing compared to dark energy. If dark matter is what holds the universe together, dark energy is what's pulling it apart. Observations of distant galaxies show that the universe isn't just expanding, it's expanding faster and faster over time. Something is fueling this acceleration, and that something has been given the name dark energy. It makes up nearly 70% of the universe, yet we have no clue what it actually is. One possibility is that dark energy is a property of space itself. Unlike ordinary forces that weaken over distance, dark energy may behave in the opposite way. The more space there is, the stronger it becomes. This means that, in the far future, dark energy could grow so powerful that entire galaxies become isolated, drifting away from each other until they can no longer be seen. And if the Big Rip theory is correct, it could eventually tear apart not just galaxies, but atoms themselves, reducing the universe to pure energy. But there are other strange things happening in the universe that challenge our understanding of physics. Take fast radio bursts, FRBs, powerful millisecond-long flashes of radio waves that come from deep space. They were first discovered in 2007, and since then, hundreds have been detected. Some happen once and never again. Others repeat, but with no clear pattern. The most mysterious thing about FRBs is their sheer energy. In just a fraction of a second, a single FRB can release as much energy as the sun produces in 80 years. So what's causing them? Some theories suggest they come from neutron stars, the incredibly dense remains of collapsed giant stars. Others think they might be magnetars, a special type of neutron star with an unimaginably strong magnetic field that can distort atoms and rip apart anything that comes too close. And then there's the more speculative idea, aliens. Some scientists have considered the possibility that FRBs could be signals from advanced civilizations. The bursts are incredibly energetic and originate from billions of light years away, meaning they were sent long before life on Earth even existed. If they were intentional signals, it would mean that somewhere out there, civilizations were communicating long before we ever looked up at the sky. But FRBs aren't the only signals we've received from space. In 1977, a radio telescope picked up something unusual, a 72-second-long signal from deep space, coming from the direction of the constellation Sagittarius. It was loud, clear, and unlike anything ever detected before. The astronomer who spotted it, Jerry Eman, circled the reading on the data printout and wrote one word beside it: "Wow." The WOW signal remains one of the greatest unsolved mysteries in astronomy. It has never been detected again, and no natural explanation has been found. Some believe it could have been a stray transmission from Earth bouncing off space debris. Others argue that it might have been a signal from an unknown cosmic event. And then, of course, there's the idea that it might have been a deliberate message from extraterrestrials. We may never know the truth, but it remains a tantalizing hint that the universe is still full of surprises. And speaking of surprises, let's talk about something truly bizarre: rogue planets. Not all planets orbit stars. Some have been flung out of their home solar systems by gravitational forces, doomed to drift through space in perpetual darkness. These are known as rogue planets, and there could be billions of them wandering the galaxy. Imagine a world where there is no sun, no daylight, only endless night. The only light comes from the planet's own volcanic activity, or maybe from a faint, glowing atmosphere created by residual heat. But here's the truly mind-bending part. Some rogue planets could still support life. If a rogue planet has a thick enough atmosphere, it could trap heat from its core, creating an environment warm enough for liquid water to exist beneath an icy surface, just like Jupiter's moon Europa. This means that even in the freezing void of interstellar space, there might be life forms surviving in hidden oceans, completely unaware that they are drifting alone through the galaxy. And if life can exist in such extreme conditions, then where else might it be? Some scientists have suggested that life might exist in places we haven't even thought to look, not just on Earth-like planets, but on exotic worlds completely unlike our own. For example, Titan, Saturn's largest moon, has lakes and rivers of liquid methane instead of water. Its thick atmosphere contains organic molecules, the building blocks of life. Could there be methane-based life forms using an entirely different kind of chemistry than anything we know? Or consider Venus. Once thought to be entirely inhospitable, recent studies have suggested that microbial life could exist in its upper atmosphere, where conditions are much more Earth-like. And then there are the truly speculative ideas: life on neutron stars, made not of carbon and water, but of exotic particles that behave in ways we can't even imagine. The universe is vast, and as we continue to explore, we may discover that life isn't just something that happens on rare, Earth-like worlds. It may be everywhere, thriving in ways we've never even considered. And maybe, just maybe, somewhere out there, another species is looking up at their sky, wondering the same thing. One of the most haunting ideas in modern physics is something that sounds like it belongs in science fiction: vacuum decay. The universe, as we know it, exists in a state called a false vacuum. That means it might not be in its most stable form. Imagine a glass resting on a slightly uneven table. It's stable for now, but a small nudge could send it tumbling to a lower, more stable position. If our universe is in a false vacuum, it means that somewhere, somehow, a random quantum fluctuation or an ultra-high energy event, perhaps near a black hole or during the collision of two cosmic rays, could trigger a process known as vacuum decay. In an instant, a tiny bubble of true vacuum would form, expanding at the speed of light, erasing everything in its path. Entire galaxies, planets, and even the very laws of physics themselves would cease to exist as this new, more stable version of reality replaced our own. The truly terrifying part? If vacuum decay were to happen, we wouldn't see it coming. There would be no warning, just instant oblivion. But before you worry too much, there's good news. Current physics suggests that if vacuum decay were possible, it likely would have already happened somewhere in the universe by now. And since we're still here, it probably means our vacuum state is stable, at least for trillions of years to come. Still, it's a reminder that the universe isn't as permanent as it seems. But while the universe might end in an instant, some things in space last for unfathomable amounts of time. Take white dwarfs, for example. These are the leftover cores of dead stars, like the sun will one day become. After billions of years of burning, a star sheds its outer layers and leaves behind a hot, dense core about the size of Earth but containing more mass than the entire sun. White dwarfs don't generate new energy. Instead, they slowly fade, cooling down over billions and trillions of years. Eventually, after quadrillions of years, a white dwarf will cool so much that it will become a black dwarf, a frozen, lightless object, the final corpse of a star. Here's the thing. The universe isn't old enough for any black dwarfs to exist yet. The first stars only died a few billion years ago, meaning every white dwarf in existence is still glowing. But in the far distant future, when the last white dwarfs fade into black dwarfs, the universe will be a very different place, dark, cold, and quiet. But not everything in the cosmos is predictable. Consider Tabby's star, one of the strangest and most mysterious stars ever discovered. Located about 1,470 light-years away, Tabby's star behaves in a way that defies explanation. Its brightness dips and flickers in seemingly random ways, sometimes dimming by as much as 22%, far more than any planet or dust cloud could account for. At first, astronomers thought a swarm of comets might be blocking its light, but follow-up studies found no evidence of comets. Others suggested a cloud of dust or debris, but that wouldn't explain the irregular and dramatic dimming. And then came the most controversial idea. What if the dimming is being caused by an advanced alien megastructure? Some scientists have speculated that the star's odd behavior could be due to something called a Dyson swarm, a massive, artificial structure built by an advanced civilization to harvest energy from the star. This idea remains highly speculative, but the mystery of Tabby's star remains unsolved. For now, the best explanation is that some unknown form of cosmic dust is responsible, but no one knows for sure. But if that's strange, it's nothing compared to the bizarre physics of neutron stars. Neutron stars are the densest objects in the universe besides black holes. A single teaspoon of neutron star material would weigh about 1 billion tons, more than all the buildings and cars on Earth combined. What makes neutron stars so fascinating is that they challenge our understanding of physics. The extreme gravity crushes atoms so tightly that electrons and protons merge into neutrons, creating a substance called neutron degenerate matter. And if you go even deeper, there may be something even stranger, a theoretical state of matter called quark matter. At the heart of a neutron star, the pressure is so intense that neutrons themselves could break down into their fundamental building blocks, quarks. This would create an exotic quark core, something we've never seen in nature before. Some scientists believe that if a neutron star is just the right size, it could collapse into something called a strange star, a hypothetical object made entirely of quark matter. If true, strange stars would be among the most exotic and alien objects in the universe. And what happens if a neutron star gets even denser? It collapses into a black hole, perhaps the most enigmatic phenomenon in space. Black holes are famous for their ability to trap light, but what's even stranger is that they might not be completely black. In 1974, Stephen Hawking proposed that black holes actually lose mass over time through something called Hawking radiation. Over trillions and trillions of years, this slow leakage of energy means that even the most massive black holes will eventually disappear. But here's the question. When a black hole evaporates, what happens to all the information it swallowed? According to quantum mechanics, information can't be destroyed. It has to go somewhere. But black holes seem to erase information completely. This contradiction is known as the black hole information paradox, one of the biggest unresolved problems in physics. Some theories suggest that information is somehow stored in the event horizon, while others propose that it might be released in a scrambled, unrecognizable form when the black hole dies, or perhaps it gets transported to another universe entirely. This brings us to one of the wildest ideas in modern cosmology, the possibility that black holes might be portals to other universes. Some physicists believe that when matter falls into a black hole, instead of being destroyed, it could emerge in a completely different reality. This idea is inspired by the mathematics of wormholes, theoretical shortcuts through space-time that could connect two distant points, or even two different universes. If true, it would mean that every black hole is not an end, but a beginning, a doorway leading to something entirely new. But for now, these ideas remain in the realm of theory. The universe still holds countless secrets waiting to be uncovered, and as we continue to look deeper into space, who knows what new wonders we'll find. There's something deeply unsettling about the idea of cosmic voids, vast empty regions of space where there are almost no galaxies, no stars, and no matter at all. The largest of these is called the Boots Void, a massive, empty stretch of space spanning 330 million light-years across. For comparison, if the Milky Way were placed at its center, we wouldn't see another galaxy for nearly 500 million years of travel at the speed of light. What's truly strange is that the Boots Void isn't just empty, it's unnaturally empty. In a universe filled with galaxies, stars, and planets, this region is eerily deserted. Some scientists have even jokingly referred to it as the Great Nothing. The leading theory is that cosmic voids form when gravity pulls matter into dense regions, leaving behind enormous gaps of nearly pure nothingness. But there's another, far stranger idea. What if the Boots Void was artificially created? Some speculative theories suggest that an extremely advanced alien civilization could have somehow removed matter from the void, either by consuming it or using energy on a scale far beyond our understanding. Of course, this is purely hypothetical, but the fact remains. We don't fully understand why voids like this exist. But the universe isn't just full of empty spaces, it's also home to gigantic structures that defy explanation. Take the Hercules Corona Borealis Great Wall. This colossal cosmic structure, discovered in 2013, stretches an astonishing 10 billion light-years across. It's so big that it violates the laws of physics, specifically the cosmological principle, which states that on large scales, the universe should look roughly the same in all directions. Yet here we have a structure so massive that it shouldn't exist at all. It's made up of clusters of galaxies interconnected by filaments of dark matter and gas, forming a structure so vast that light itself takes billions of years to travel across it. Some scientists believe that structures like this are leftovers from the early universe, remnants of a time when the cosmos was still settling into its current shape. But there's another, even weirder possibility. What if these enormous structures are a sign that the universe is actually part of something even larger? One theory suggests that our universe could be just a tiny bubble in a vast multiverse, with other universes beyond our own. If that's true, these giant cosmic structures might be clues, evidence of collisions between universes, where our reality brushes up against another. And if the multiverse is real, it raises an even bigger question. Are there other versions of you out there? The concept of the many worlds interpretation of quantum mechanics suggests that every time a decision is made, reality branches, creating a new universe where the opposite choice was taken. This would mean that there are countless parallel versions of you, living out different lives in different realities. Maybe in one universe you chose to live in a different city. Maybe in another you never existed at all. And maybe in some distant branch of the multiverse, an entirely different version of Earth evolved. One where history played out in ways we can't even imagine. But if parallel universes exist, could we ever reach them? Some scientists believe that black holes might be gateways to other universes. According to one theory, when a black hole forms, it doesn't just collapse into a singularity. Instead, it might spawn a new universe on the other side. If true, it would mean that every black hole is the birth of a new reality, with its own stars, planets, and physical laws. And if black holes lead to new universes, then what about the one we're living in right now? Could our own universe have been born from a black hole in another reality? This idea, known as the black hole cosmology hypothesis, suggests that the Big Bang wasn't the beginning of everything, but rather a transition, the moment when our universe emerged from a black hole in a parent universe. If true, it would mean that reality is an infinite web of universes, each giving birth to the next in an endless cycle. But as vast as the cosmos is, we're still looking for something very specific: life beyond Earth. One of the most exciting places to search is Enceladus, a tiny moon of Saturn. At first glance, Enceladus looks unremarkable, a frozen, icy world smaller than some countries on Earth. But beneath its thick ice shell lies something incredible: a massive global ocean, hidden from view, but warmed by powerful tidal forces. In 2005, the Cassini spacecraft flew past Enceladus and detected plumes of water vapor erupting from its surface. These geysers contained organic molecules, the basic ingredients of life. Even more astonishingly, follow-up studies suggested that these plumes might contain hydrogen gas, a key energy source for microbial life. This means that right now, beneath the ice of Enceladus, there could be alien microbes swimming in dark, hidden oceans, completely isolated from the rest of the universe. And Enceladus isn't the only promising candidate. Europa, one of Jupiter's moons, also has a vast underground ocean with signs of thermal activity that could support life. Even Titan, with its methane lakes, could harbor strange, exotic organisms that use liquid hydrocarbons instead of water. But what if life isn't just limited to planets and moons? Some scientists believe that life could exist in the atmospheres of gas giants. Imagine an enormous, Jupiter-sized world with floating organisms drifting in the thick, swirling clouds, feeding on chemicals, absorbing sunlight, and thriving in the upper layers of the atmosphere. And if life can exist in such extreme environments, then where else might it be? Some theories suggest that life might not even be carbon-based. Instead of the familiar building blocks we know, alien organisms could be based on silicon or even more exotic materials. Perhaps life forms that exist as pure energy, intelligence without physical form. It's possible that life is far more common than we ever imagined, not just microbes or simple organisms, but intelligent beings scattered across the cosmos. And yet, in all our searching, we found nothing. This is the heart of the Fermi paradox, the contradiction between the high probability of alien civilizations existing and the fact that we have found no evidence of them. There are many possible explanations. Maybe intelligent life is rare. Maybe advanced civilizations don't use radio signals, or maybe they destroy themselves before they can explore the stars. Or maybe they're already here, and we just haven't noticed them yet. Some scientists speculate that aliens could be using cloaking technology, hiding their presence from us the way we might avoid disturbing an ant colony. Others suggest they might communicate using methods beyond our understanding, like neutrino beams or quantum entanglement. And then there's the unsettling possibility that we're simply alone, that in all the vastness of the cosmos, we are the only ones who have ever looked up at the stars and wondered if someone else is looking back. If that's true, then the universe isn't just vast, it's silent. But the search continues, and as we push further into the unknown, the greatest discovery in history might be just around the corner. There's something haunting about the idea that time itself might not be what we think it is. When we look up at the night sky, we're not seeing the universe as it is right now. We're seeing the past. Light takes time to travel, which means that when you look at the moon, you're seeing it as it was 1.3 seconds ago. The sun, 8 minutes ago. But the Andromeda galaxy, the closest large galaxy to us, appears as it was 2.5 million years in the past. Now, stretch that idea even further. Some of the galaxies we see in deep space don't even exist anymore. Their light has taken billions of years to reach us. By the time that light finally arrives, the galaxies could have collided, transformed, or completely vanished. But what if the universe isn't just showing us the past, but also the future? Some physicists believe that time is an illusion, a byproduct of how we perceive the universe. Instead of flowing like a river, time may be a static dimension with the past, present, and future all existing simultaneously. We just experience it one moment at a time. This idea is called the block universe theory. According to this concept, every moment in time, past, present, and future, already exists. Right now, your future self is already there, just as real as your past self, but you can only experience time moving in one direction. But if the future already exists, could we ever reach it? Some solutions to Einstein's equations suggest that time travel might be possible, at least in theory. If we could approach the speed of light or orbit near an extremely massive object like a black hole, time for us would slow down, while the rest of the universe would speed ahead. This means that technically astronauts could travel far into the future just by flying near a black hole and returning to Earth. While they might only experience a few years, centuries, or even millennia could pass back home. But what about going backward in time? That's where things get weird. Some theories suggest that wormholes, hypothetical tunnels in space-time, could allow instantaneous travel between 2 points, even if those points exist in different times. The problem? Wormholes might be inherently unstable, collapsing the moment anything tries to pass through. And even if we could stabilize one, there's the question of paradoxes. What happens if you go back in time and prevent your own existence? The laws of physics don't seem to like that. Even stranger is dark energy, a force that seems to be pushing the universe apart faster and faster. Instead of slowing down, the expansion of the universe is accelerating, driven by this unknown energy. What is it? We have no idea. Some theories suggest that dark energy might be a property of space itself. The more space there is, the more energy it creates, causing expansion to speed up indefinitely. Others propose that dark energy could be an entirely new force of nature, one that we're only beginning to uncover. And then there's an even wilder idea. What if dark matter and dark energy don't exist at all? Some scientists argue that our understanding of gravity might be incomplete, that the strange movements of galaxies and the accelerating universe might be the result of a deeper, undiscovered law of physics. If that's true, then our entire picture of the cosmos might be completely wrong. But what if there's another answer, one that suggests the universe is far stranger than we ever imagined? Some theories propose that our universe might be a simulation, a vast artificial reality created by an advanced intelligence. This idea, known as the simulation hypothesis, suggests that everything we see, from galaxies to atoms, could be a highly advanced program running on a cosmic-scale computer. It might sound like science fiction, but some physicists take it seriously. There are strange patterns in the fundamental laws of physics, things that seem too perfect, as if they were programmed. Some experiments even suggest that the universe has a built-in resolution limit, similar to how pixels work in video games. If that's true, then everything, our memories, our experiences, our reality, could be nothing more than data in an incomprehensibly complex system. And if the universe is a simulation, then what happens when the program ends? Could there be a moment when everything simply shuts off? Would we even notice? Or would the illusion continue, seamlessly replacing reality with a new version, erasing any trace of what came before? If that idea is unsettling, here's another. What if death isn't the end, but instead just a transition into another form of reality? Some physicists suggest that consciousness might not be tied to the brain alone. Instead, it could be a fundamental part of the universe itself, woven into the fabric of space-time. This idea, called panpsychism, proposes that the universe isn't just made of matter, it might also be made of mind. If that's true, then death might not be an end, but simply a shift in awareness, like waking up from a dream into something even greater. Perhaps, just like the universe itself, we are far more than we appear to be. And as we continue exploring, pushing the limits of what we know, we might one day discover that reality is even stranger, deeper, and more mysterious than we ever imagined. If you've ever looked up at the stars and thought about how incredibly vast the universe is, it's hard to truly grasp its scale. The observable universe, the part we can see, spans an astounding 93 billion light years. But even more mind-boggling is the fact that the universe might be much bigger than what we can see. In fact, it could be infinite, meaning that beyond the limits of what we can observe, space continues forever. This idea seems almost incomprehensible, but it's a real possibility. Some cosmologists propose that beyond the edge of the observable universe, there could be an infinite number of galaxies, stars, and planets, stretching out beyond our wildest imagination. But here's where it gets strange. The universe is expanding, and it's doing so faster than the speed of light. This isn't a violation of relativity, though. It's just how space itself works. As space expands, it doesn't drag galaxies along with it. Instead, it stretches space itself, causing distant objects to move away from us faster than light. This phenomenon means that some galaxies are already beyond our reach, and no matter how much technology advances, we'll never be able to visit them. They're simply moving too fast, forever beyond the observable universe. And if that's not mind-blowing enough, consider the possibility that the universe might not even be real. The idea of the holographic universe suggests that the entire 3D world we experience could be a projection, like a 3D image created by a computer, but far more advanced. The theory posits that all the information making up the universe could be stored on a 2D surface, much like how a hologram creates a 3D image from a 2D surface. Some scientists believe that the laws of physics, as we understand them, might be entirely based on these 2D data layers. It's a wild thought, but the evidence is starting to suggest that this could be true. There are patterns in the cosmic microwave background, the afterglow of the Big Bang suggests the universe might be a projection of something far more fundamental, hidden beyond our perception. This idea raises even more unsettling possibilities. What if our entire existence is just an illusion? What if every thought, every action, and every star is a programmed construct, and we're simply the players in a cosmic simulation? On a related note, there's a hypothesis that proposes the universe itself could be the product of an advanced computer system, possibly designed by an intelligence that's far beyond our understanding. In this view, everything we know, from the stars to the laws of physics, is merely data in a giant cosmic computer. But if our universe is a simulation, who or what is controlling it? Are we the result of an experiment, or perhaps the creations of beings who are themselves unaware of the deeper nature of the reality they exist within? This idea might seem like pure science fiction, but there are serious thinkers who believe that it could be possible. In fact, there's even a growing movement within the scientific community exploring ways to test whether our universe might be a simulation. And if we are part of a cosmic simulation, that would suggest that anything is possible, from time travel to alternate realities and beyond. Could it be that our simulation is just one of many, with alternate versions of Earth and endless possibilities unfolding in parallel universes? Another possibility is that we might be living inside a black hole, or rather a universe inside a black hole. When you think about black holes, you probably picture immense objects with gravitational pull so strong that nothing, not even light, can escape. But what if that pull wasn't just an ending? It could be a new beginning. Some scientists suggest that black holes could be portals to other universes. This idea stems from the fact that a black hole's core, known as the singularity, is thought to hold all of a black hole's mass in an infinitely dense point. The extreme conditions inside a black hole might allow for the creation of a new universe, a big bang-like event that spawns an entirely new cosmos on the other side. But if that's true, it would mean that our universe could have been born from the collapse of a black hole in a previous cosmos. This is called the black hole cosmology hypothesis. According to this theory, every time a black hole forms, it could generate a new universe, and the cycle repeats infinitely. In this scenario, the black hole would be a gateway to a fresh start with a new universe unfolding inside. If this theory is true, then our universe might not be the only one. It could be one of countless parallel universes, each one born from a black hole in the cosmos before it. But black holes are not the only place where extreme phenomena occur. In fact, gamma-ray bursts are some of the most powerful events in the universe, capable of releasing more energy in a few seconds than the sun will release in its entire 10 billion-year lifetime. These bursts of gamma rays are thought to be the result of a massive explosion, often the death of a star, that sends out a burst of radiation in the form of high-energy photons. These explosions are so intense that they can briefly outshine an entire galaxy, making them one of the most energetic phenomena we've ever observed. Gamma-ray bursts are often linked to supernovae, when a massive star runs out of fuel and collapses in on itself. But some gamma-ray bursts appear to originate from hypernovae, even more powerful explosions caused by the collapse of stars far larger than our sun. These bursts can release energy in the form of gamma rays that travel across vast distances, sometimes for billions of light years, before reaching Earth. The cause of gamma ray bursts isn't entirely understood, but their sheer intensity means they're capable of disrupting the very fabric of space-time. If one of these bursts were to hit Earth, it could wipe out the ozone layer and cause mass extinction. Fortunately, they're incredibly rare, but it's a reminder of just how dangerous the universe can be. Then there's the phenomenon known as rogue planets, planets that don't orbit any star. These free-floating worlds drift through space, completely isolated from the gravitational pull of any sun. Some scientists believe that there could be billions of rogue planets wandering the galaxy with no star to light their way. Rogue planets might be born in the debris left over after a planet's star goes supernova, or they could have been ejected from their home star system after a gravitational disturbance. Some rogue planets might even have subsurface oceans, warm, liquid environments where life could potentially thrive. If life can exist on Earth without sunlight, why couldn't it also exist on rogue planets? These dark, lonely worlds could harbor life forms completely different from anything we know, thriving in the icy depths beneath their frozen surfaces. The idea of rogue planets is fascinating because it suggests that the universe could be home to many worlds that exist entirely outside the norms of what we expect. We've seen the grandeur of the universe, but what about the smallest, most fundamental building blocks of reality? The universe may be vast, but at its core, everything is made up of tiny particles, and one of the most mind-bending phenomena is quantum mechanics. The theory that governs the behavior of particles on the smallest scales seems to defy all logic. For instance, particles can be in multiple places at once, and when observed, they choose a location, collapsing into one place only when we look at them. This strange phenomenon is known as quantum superposition. It's as if the very act of observing reality shapes it, and the outcome of events isn't determined until it's witnessed. In a way, this makes the universe seem like a giant interconnected web of probabilities, where everything is in a state of flux until we interact with it. But it gets even weirder. There's something called quantum entanglement, which involves two particles becoming linked together, no matter how far apart they are. If you change the state of one particle, the other instantly responds, even if it's light years away. This instantaneous communication between distant particles seems to defy our understanding of space and time. Albert Einstein famously called this phenomenon spooky action at a distance because it suggested that information could travel faster than the speed of light. But oddly enough, quantum entanglement has been confirmed through experiments and is now a cornerstone of quantum physics. One of the most fascinating potential applications of quantum mechanics is the possibility of quantum computers. Unlike traditional computers that store and process information in bits, ones and zeros, quantum computers use quantum bits or qubits, which can exist in multiple states at once. This allows quantum computers to perform calculations at speeds far beyond the capabilities of our current machines. In the future, this could revolutionize everything from cryptography to artificial intelligence, making technology exponentially more powerful. And while quantum mechanics seems almost like magic, it's the foundation of the very fabric of reality. Everything we see, feel, and experience is governed by these strange rules on a microscopic level. Speaking of fundamental building blocks, there's another fascinating concept called string theory. String theory proposes that the basic particles we think of as matter, electrons, quarks, and others, are not point-like particles at all, but instead are actually tiny, vibrating strings of energy. These strings are so minuscule that we can't detect them with our current technology, but they might be the key to unifying the forces of nature. String theory is part of the search for a theory of everything, a single, all-encompassing framework that explains how the universe works at both the macroscopic and microscopic levels. String theory also suggests the existence of extra dimensions, beyond the familiar 3 dimensions of space and 1 of time. These extra dimensions might be curled up so small that we can't perceive them, but they could be hiding the answers to some of the most fundamental questions about the universe. One of the most mind-blowing implications of string theory is that there could be parallel universes, each with its own unique laws of physics, hidden just beyond our grasp. These universes might be similar to ours, but with slight differences in how the fundamental forces operate, leading to radically different outcomes. There's also the possibility of an infinite number of parallel universes, which leads to the idea of the multiverse. According to this theory, our universe might just be one of many, each existing in its own separate bubble, with different physical laws governing each one. Some of these universes might be vastly different from our own, with entirely new forms of matter and energy, while others might be nearly identical, differing only in a single event or particle. The concept of the multiverse raises profound questions. If there are infinite versions of reality, does that mean that anything is possible? Could there be universes where every choice we ever made leads to an alternate version of ourselves? What does it mean for us if we are just one of an infinite number of parallel selves? But even if we can never truly access these alternate universes, the idea of infinite possibilities is a humbling one. It makes us realize how much of the universe is still out of reach, how much we don't understand, and how much we'll never know. Beyond the abstract concepts of quantum mechanics and string theory, there's something that truly captures the imagination: the search for extraterrestrial life. For centuries, humanity has wondered if we are alone in the universe. In recent years, the discovery of exoplanets, planets orbiting stars outside our solar system, has opened up new possibilities. Scientists have identified thousands of exoplanets in the so-called habitable zone, the region around a star where conditions might be right for liquid water to exist. Some of these planets could harbor life, perhaps in forms completely alien to anything we know. In fact, the discovery of extremophiles, microorganisms that thrive in the most extreme environments on Earth, suggests that life could exist in environments far harsher than we ever imagined. But the question remains: have we already discovered evidence of extraterrestrial life and we just don't know it yet? Some scientists speculate that we might have already detected signals from alien civilizations, but misinterpreted them. The search for technosignatures, signs of technological activity from distant civilizations, is an ongoing field of research. From unusual radio signals to mysterious bursts of energy, there's still a chance that we could find signs of intelligent life out there. And who knows, maybe we've already been visited. Perhaps interstellar travelers have already come to Earth, but they've been so advanced that we didn't even notice. In the future, as our technology advances, we might find ourselves making contact with civilizations far older, wiser, and more advanced than us. That thought opens up yet another realm of possibilities. If we do make contact with extraterrestrial civilizations, how will we communicate with them? Could we even understand each other? Or would their concepts of reality be so different that communication would be impossible? The answers to these questions are still far beyond our reach, but the search continues. In the end, the mysteries of space and the universe are boundless. We may never understand everything, and we may never uncover the full scope of reality. But as long as we keep looking, we will continue to uncover new wonders that challenge everything we think we know.